Gases and gas laws are a great place to be asked questions where you're applying knowledge from a graph. So we don't need to know which law is which. We just need to be able to understand when reading a graph what information is presented to us and maybe why it's presented in that way. Boyle's law, which says that pressure and volume are inversely proportional, would show that the higher the volume, the farther we go to the right, the lower the pressure. In this case, we would have asymptotes at both zeros here since we can't have zero volume or zero pressure. But as we approach those, the other value becomes infinitely large. The other thing to note is that at different temperatures, the exact ratio would be slightly different because the particles would be moving at different speeds and therefore exerting different pressures at the same volume. Charles and Gay-Lussac's law are both direct relationships. An important piece with this is that the temperature must be in Kelvin. The reason for that is if we have our temperature in Celsius, then we would be ending up with negative temperatures. We can graph that way, but we would have our x-axis or our 0 point would be somewhere here, and then we would be going back to negative 273. The dotted lines here are to show that if we wanted to go all the way back to our origin, we would be extrapolating or estimating that value beyond what we can measure. So even though in theory we could keep going down, 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 for most gases at a certain low temperature, we start to liquefy and then solidify. So we wouldn't really have data all the way down, even though the lines point that way. Once again, we could have different pressures that would cause a different volume under the same temperature, or a different volume here, meaning that the same temperature would take up more space to give us a certain pressure. Avogadro's law is not often one that we do mathematically, although it is what allows us to apply Avogadro's number and do the ideal gas law, but it's just telling us that the more particles we have, the more space that would take when everything else is constant. And this is one that truly would have a 0, 0. No particles occupy no volume. The other thing to note is that we can take these same graphs and linearize them in different ways. You're not always presented with the data in the way that you are used to it. An inverse relationship, for example, we could do pressure times the inverse of volume, pressure times the inverse of volume, or we could even do volume with the inverse of pressure. And in that case, we would see a certain defined positive straight line, or we would see a positive line with a slope. We can also graph different variables times one another as pressure or volume or moles or temperature changes. So no matter what you're presented, it's very important that you understand the data on the axes and how that's showing what's going up and what's going down in different scenarios.